So, as the title suggests, we're going to be doing some late night programming. I'm just going to be working on a dungeon generation algorithm to hopefully put into a game. Hopefully being the operative word there. Let me just actually, let me just do my whole desktop. There we go. And then transition that. Awesome. Cool. So now you guys can see my stuff. This is just going to be a simple console app. I'll just display numbers or letters or something in reference of where I want the tile to be. Just because I don't need the graphics or anything like that. I just want the bare bones functionality of the whole thing. And hopefully once I get that down, I could make it pretty plug and play. But we'll see. Got a bug in my throat as well. So right off the bat, the first thing I want to do is get a text file in here, because that is going to be my pseudocode. So that way I have my process to follow. So we want the function. We want it to build dungeon. Let's just start. Do enter build dungeon. Either fireworks or gunshots outside. That's awesome. I should probably change my music so I don't get copyright flagged. Let's just do stream music. There it is. Okay. Perfect. Okay. Enable build, enter build dungeon. So right off the bat, we want to with room size, we'll say vector 2D. With room size min/max as vector 2D. And then we'll just start there. We'll start with just placing a single room into the world. So we have the room size min and max as a vector 2D or a coordinate pair. So for that, then we would want to, and actually we'll just even make this more simpler. We'll make this more simple as float and room size max as float. So we're not even using any special classes, it's just float. And we could probably make those ints or even shorts if we're really trying to save space, but float will be good because I doubt, you probably don't want a room size that's on a decimal. You'd probably want a whole number, but we do float that way. It gives a little bit more flexibility. So then once we have that, we want to loop through sorry, I'm just trying to think. So we want to loop through what would be our world. Loop through the X So going across through x plane, x dimension. Loop through x until right. So okay, we'll do this for now. Sorry, I guess I should enunciate my thoughts. At some point, we would want this room size float and room size min and room size max to be like I want that vector 2, because then we would do a room size or room width min and max and a room height min and max. But if we do this bare bones, just to start, and actually if I do this, so these are my parameters. And then once we're in the program, so I'll even indent a little bit further. Then we want to declare new float. Declare new float room size equal to random float between the room min and room max. So once we have that float, once we have that room size, then we can say, okay, loop through x until x is equal to the room size. And while we're looping through, before we do that, we would want to loop through y until y equals the room size. And then then we would want to loop through the x. So we'll start on y equals 0 and then go through the x's. We're done with all the x's, y will increase, y equals 1, go through all the x's. It's kind of how that works. It's a little backwards, but you think of it that way, then it makes sense. So then we end that loop, and we end that loop. So once we have this, then so once we have that, then we can we establish the room. So this is where we're looping through each tile of our room and placing something down. And we're gonna have 9 different tiles. So you would have the I'll use cardinal directions. It'll be, consider this a 2D a two-dimensional top-down dungeon. So you'll have the north wall, the south wall, the east wall, and the west wall. And then you have the northwest corner, northeast corner, southeast corner, southwest corner. Thank you, Justin. Thank you for coming in here and calling me a nerd. I appreciate it. And then along with, so those would be 8 for just the walls, and then your floor. That would be the 9th tile. So with that, then, so as we're looping through, then we'll check if, we'll start with the corners. I haven't touched code in like 6 months. I haven't touched code that wasn't for work in, yeah, probably a few months. Like, because I program for work, but like I haven't touched my own personal projects in so long. So I thought, you know what, I'm gonna do that tonight. Yeah, so we're gonna start with the corners then. So if x is, so we'll start it simple. Our origin will be 0, 0, and that will be the top left. That'll be the northwest corner. So if x is equal to 0, then place northwest coroner, and y is equal to 0. So if y and x are 0, 0, it's northwest corner. Else, if x is equal to the room size, right? Room size, or room size minus 1, and y is equal to 0, then place northeast corner. Else if, so that's the x's done. So then we're doing the same thing essentially for the y's. So if y is equal to room size minus 1 and x is equal to 0, then place the southwest corner, and then else if y is equal to room size minus 1 and x is equal to room size minus 1, then place the southeast corner. So that is the corners then. Do a little of that. I'm going to put a comment in my pseudocode because that makes sense. So that's the corners. And we could even potentially break this out into its own function. So we could just say else if it's, well, we'll leave the else if there. But we could break this out into its own function of place corners and then and then we could do stuff with depending on where the last room was, create a new room based off of those coordinates. So then we're able to sort of shift it while still maintaining the simpleness of the code. So we'll say place corners, execute place corners. And then, so if we do it in a function, then we can have parameters, start x as float. I am never gonna not type flayot instead of float. And start y as, damn it, as float. And then we can pass it the room size as well. So then instead of 0, it's start x for both x and instead of 0 for y, it's start y. So that gives it a little bit more flexibility rather than, okay, we can only start at 0, at 0, 0. This can let us, right from the get-go, kind of move this around. Okay. End place corners. I don't know what I just right-clicked. Now I gotta wait for Visual Studio to do its thing. Okay. think I ran a... Oh, yeah. Not going to do anything on a text file, so... There we go. And then execute place coroners. God, I can't talk. With, we'll just say 0, 0, and room size to start out with. Oh, shoot. We have to actually pass it x and y as well. X as float. And y as float. There we go. So 0, 0, x, y, and room size. Okay, cool. So that's corners done, essentially. And then we would want the walls. So again, we can break this out into into a little function. Enter place walls with parameters. Start x as float. Start y as float. X as float. Y as float. And room size as float. So now this will be so I'm just trying to think. Okay, yeah. Right now this probably isn't the best way because, like, place corners, place walls, and then eventually place floors are all gonna run on each iteration, each loop of x and each loop of y, so each loop of x. So, but for like place corners, it won't place any corners if the x's don't line up. But we would have to, yeah. So it won't be a problem. It won't overplace anything or place duplicates, but it is going to run and make every check every time. So we could put a check in here that's just if x is not 0 or room size -1 and y is not 0 or room size -1, then just exit out of this, so continue is the keyword for that. Otherwise, it's just going to come down here and do its thing. There we go, problem solved. And this one we want to run every time anyway, just because there's going to be more walls than corners. There's only going to be 4 corners. We only want this to run 4 times, but for walls, they could run any amount. Well, I take that back, because we only want walls to run if we're literally on the border on the wall. Well, let's get it started first before we do that. Let's go into our checks before we even do this, so we know what we're working with. So if we think of our square, where we've taken out 0 and the room size -1, so the 0 and the max, we've taken those out. And we're left with infinitely anything in between. So we want to check on each loop if x is equal to so if x is equal to 0, then if x is equal to 0, I just thought too, we would want the opposite of this, basically as our... So if x is 0 or room size, and if y is 0 or room size, then exit out. Because then we don't want it to hit those corners and place walls over top of our corners. Big brain, big brain. So yeah, so if x is 0, then place wall north wall. Else if x is equal to room size minus 1. Yeah. No, sorry, we're doing x, so it would be, if x is 0, we're on the left side, so the west wall. And if it's room size minus 1, then we want to place the east wall. Right? Yeah. So then, else if y is equal to 0, hitting everything but what I want, then we want to place the north wall, so we're at the top of the room. And then else if y is equal to room size minus 1, place south wall. And in theory, I really don't need that last else if, because we're eliminating corners here and we're eliminating everything else that's not a corner here. So by the time we get down here, we know it's going to be this, but just for readability, it's just there. And then, yeah, so we have place walls with... So again, it would be our starting coordinates. So 0, 0, x, y, and room size. And then we come back here and place walls. So that's good. Awesome. So then the last thing is the floors. And again, same thing. Break it out into a separate function, and that allows us to get a little bit more flexible with it. Place floors. And again, I'm just going to do this because I already know 0, 0, x, y, and room size. So this is just, like I said, we're building one room. This will be like the initial first room. So it's always going to start with 0, 0. But once we get more into it, that will change. That value will change. And so we already have the place walls and place floors. So basically, this one's really easy because we can just copy this and then get rid of 90% of it. Because we're just going to check. So if it's... Wait. Hold on, I might have spoke too soon. It's going to be the opposite of corners and walls. So walls is... Let me pull up paint real quick. So we have our square, right? So corners is just these, literally the corners. And that's x room. I'll just do room for room size, and then right. So this is x and y 0, room size and x. No, room size and y. X and room. Roo. And then room and room. We'll do room squared. And then so that's that. And we don't want that. We don't want that for floors, so we can get rid of these. So it's not x is 0, y is 0, or either of them being room size minus 1. But also, we need this. And so we need these then. Which is only checking for, so, x, room, and y, room. But we want to get rid of those as well. So if x is equal to 0, so we're in a corner, or we're at the left side, or so if x is equal to 0 and room size minus 1, and y is equal to 0 or room size minus 1. I think we want or on that as well. And then, so if it's that at all, then it's anything in that perimeter, continue. Otherwise, place floor. So that one's simple. I say that, let's test my theory. And I'm gonna make a new file. I don't want to use the program. I just want to be able to quickly extract this out of the program when I'm done with it. So we'll do dungeon generation. Okay. So we'll pull this over here so I can still see my pseudocode. And we already know right off the bat we want 3 functions. We want, these will probably be private, place corners with float. Oh my god. Start x, float start y, state y. Jesus Christ, Ray, come on. Float x, float y, and float room size. And then just copy that 3 times. Private void place corners. And then we'll do place walls and place corners. Did I spell that? Okay, no I didn't. Okay, I thought I spelled that wrong. Oh, sorry. Place floors. There we go. So, following that logic, and I'll do a generic here real quick. Because like I said, I want this to be able to be plug and play and do whatever I need to with it. And I'll try to figure out more with the generic type, but this way I can just say, hey, it's of type list, or it's of type int or type whatever, and quickly just get the results that I want. This is going to be a public class. And it'll probably be static as well. It's not going to be a... We're not saving anything to the object, we're just using it to create the thing. But we do want a private... Do private for right now. No, we want it to be public. We want to be able to access this. We could have the function return it. Sorry, this is how my brain works. Actually, in that case, then we could just do. I need to end this as well. End dungeon build, whatever I called that. So we want public stat. My fucking 3D printer like masking tape thing just fell. Awesome. Public static void list. I'm just trying to. We'll do IEnumerable. IEnumerable. I'm just trying to figure out the best way of doing this. That lets me get the most usage out of it. So I don't want to like force a list or an array onto people. Just do an IEnumerable. Then you can do whatever enumerable listing set you would prefer. And then it's of type T that we're passing in the class declaration, so that it can be whatever we need. And we'll just call this build dungeon. And we want the float max room. Float min width. Float max width. Float. I'm preparing for the next few steps. That's why it's a little bit different than what I did over in the pseudocode. Min height and float max height. Okay. While we're in it, we're just going to use a list, private list of type T, temp equals new list. Because then I think I could just return temp. Ooh. 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 How do we... Oh, wait. Sorry. I'm an idiot. There we go. Okay. And then I think I can just return temp. I don't think I have to do anything special with that. I think that just works. What? 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 Expected... Yeah, you got that. Weird, I put an extra thing at the end. No. No, I didn't. That's supposed to be there. How did I manage to break this already? Let's get rid of that. It's weird. Hit that, hit that. Okay. Private A. Private static list of type T. Temp equals new list of type T. Yeah, weird. Just because I'm saying private there? Gotcha. Okay. Weird. I guess that makes sense. Wow, I had a major brain fart on that one. I swear I've written C# for years. Go me. And then return temp. And like I said, I can return this. Yeah, no problem. So it sees that as an IEnumerable. I don't have to change anything on this end. I can still work with a list, which is very easy to use. Perfect. So like I did before this, we want to create that float. Room size. For now, we're just going to do the random... random rand equals new random, and this is going to be a static rand equals rand dot next double, next bytes, no, next double, but that returns a double. Okay, fuck it, we're changing it. Wait, yeah, this can't take floats, so we'll take the min width and the min height for now. Like I said, I'm preparing with the parameters to take this later, but for now we're going to keep it simple and just simply make a square room. I could probably do a short, but if we want a room for whatever reason that's bigger than, was it 255, then probably be best to do a int. We're just gonna do a control F replace all float with int current document. Perfect. Okay, so we have our random room size now based on the minimum width and the maximum width. So then we want a for int y equals 0, y less than room size minus 1, I less than room size, right? Yeah, because once we hit room size, so I less than room size, and then y plus plus, and same thing, but for x. So int, is this, okay. I'm just setting my playlist to loop so I don't get any actual copywritten music, because that would be awkward. Awesome, okay. So that's done, and then we make our calls to, these are not static. That is the one problem with static, is everything has to be static. But that'll work in the end, because I don't want a whole object in memory for this. I just want to run it, get the room back, and then be done with this event. That's really complicated homework, man. My brain hurts. This isn't homework. I finished up my homework, so now I'm doing something that's actually fun. But yeah, welcome to what I do every day in my life, AJ. This is programming. So we're gonna loop through y, loop through x, which is gonna be, like I said, the going across the x's, move down a y, going across x's, move down a y, going across x's, like a printer. So then place corners with the re times 2. So our start x is just going to be 0, start y is just going to be 0, and then x and y's that we're currently on, and then the room size. And we'll just copy that 3 times and do place walls and place floors. Awesome. I'm going to change it up again. These aren't going to be void. These are going to return type T to the list. So temp.add and then place corners. And it's not going to be happy about that at first, but we'll change it to be according. Because that'll be better then, and then I don't have to send the list down. I'm just adding on at the end. You might argue and say that's not the best idea, but I think that's... Oh, I don't need I just need T, static T. There we go. Again, I swear I've programmed in C# for years, and I know what I'm doing. Okay, so now the problem is that they don't return values, but they work up here because now we're adding type T into a list of type T. Awesome. Um, so now we've set up this function and essentially laid the groundwork for it to be a little bit more modular and plug and play. Solid, like when that happens. So now let's just go down the list, start do the place corners function. So we have our parameters, and then let's start with that first line. So if x is not equal to 0, okay, so we don't want it to be equal to 0 or room size minus 1, so and x is not equal to room size minus 1. And then we want another set of parentheses here for the y's. I just like to keep my stuff grouped up in a way that makes sense. But then we're going to do the same thing. So instead of x, we're doing y. Yeah. So if it's like that, then just continue. Ooh. Okay. Yeah, continue won't work. Because we're not in... Wait. No, continue should just break us out of the function. A closing loop of which to break or continue. Oh, sorry, not continue. Return. But it won't let me return nothing because it is a type expecting a return. But I don't want to return null. Okay. Okay. Alright. Now, fellas. See, this is where I deviate from the original plan and I screw myself up. Try to be slick. Because I don't want to return null. I don't want to fill the list with a null value. That will mess it up. But I guess I could just remove all nulls at the end. So, yeah. Oh. Default G. Hey! I learned that new. That's new. Default can be expressed. Oh, just return default. That's awesome. That is cool. I like that. So whatever the default value is... Oh, but if it's an integer or something like that... We'll roll with it. We'll see if I like that. I'm back. I had to use the John Reed. I don't think he'd like you using his name in vain like that. Oh, but we don't want 0. We want start x. And start y. There we go. And then I'm just going to copy this over because that is pretty much actual code. I just gotta place the parentheses around it, and I'm just lazy and don't really want to type it all out. Welcome to my brain. And these can be comments. Look at that. Get rid of the thens. And then let's just do this to... Oh, it's not going to do it. Okay. I just wanted it to quickly reformat everything, but there we go. Awesome. Okay. Okay. I have said okay and awesome too many times tonight. Okay. So now, place the northwest corner. So this is where, so we would want something, this would need some kind of definition of what these are. It would need it would need that information. Um, which we could give it. It would float outside with the. You know what? Here's where I second guess myself again. We're gonna get rid of the static. It will float in memory. Because then we can have, if we would like, we can have multiple generation models open. Yeah. So we'll make it an object, yeah, instantiable object. And then so we'll have random. That's still fine. That's private. But then we'll have on it our definitions. So then we'll just do public. This will be easy. Public object. Private. Public object. And it's going to be a constant or a read only. Oh, read only. Right? Oh, yeah, that's not a keyword that they like. That's fine. It's going to be a read-only constant that we set at runtime. So not a constant in the compiler sense, but it shouldn't be changed once the creation model, the generation model is created. So this will be north wall get and private set. North wall, south wall, and it's objects, so it can be anything we send it. Makes it a little bit easier. East wall. Again, there are probably there's a simple way of doing this of just saying okay, make it an integer or whatever. But this way it's a little bit more plug and play. So if it's an object, I can send it an integer and it still works fine. But I could also send it an image or a piece of text or whatever I want. So it adds to that modularity of it all. So then I want north, west, northwest, corner, northeast, corner, southwest, corner, and southeast, corner. Awesome. And like I said, these are going to be constants to our sake. So I'm doing it all capitalization. I'm doing a constant format of the name of the variable name. That way, when I'm typing it, I know that it is a constant, unchangeable value. Again, not unchangeable in the normal constant sense where it's a constant to the compiler, but rather to just the model itself. And then floor. Get private set. Awesome. I'll just do a region model constants. Hashtag end region. And now I can just close that up. I don't need to see that anymore. But at some point then I will run or I will have to make a constructor that you can feed the values in for the model constants. Awesome. So now what we want to do then is add crap. Okay. Nope, sorry. I'm an idiot again. These objects just have to be type T. Because I want them to be the same as what the model expects, because that's what it's going to get fed into the object, into the list at the end, the generator. Sorry, that was my mistake. That was a lot of wasted explanation, but same thing. Like it's the same modularity. And then so let's just return. So return northwest wall. Northwest corner, sorry, excuse me. Doot, doot, and doot. Else, return default. So hopefully we never get down to that else statement, but if we do, we return default. And we'll see what that value is for different things. I assume for like integers or number variables, numeric type variables, it will be 0 instead of null. But that's okay. We can work with that. We'll just have like tile IDs that are not 0. Sorry, I'm blanking out. Southeast corner, where we have your corners on the corner. Okay, awesome. So place corners is done. Solid. And then, okay, I'm not gonna copy that. I'll write it again. I will copy this because we want the opposite of this. And actually, I need to get better at writing comments in my code, so what better time than to do it live, so that people think I actually do it. If the x and y value pair does not equate to a corner, then return the default value for type T. If x and y equates to top left corner, if x and y, oh, I need comments. If x and y equates to top right corner, if x and y equates to bottom left cornet, and finally if x and y equates to bottom right corner. Awesome. Okay, so now we do the walls, which is everything along the side that isn't a corner. So we want to do if x is equal to start x, or x is equal to room size minus 1, and if or yeah, there we go. Okay, so this just says if x, basically if x and y are either either 0 or room size minus 1, just return the default value for type t and stop execution of this function. I have been going for almost an hour now, and I haven't even tested this to make sure it works. I am a very slow programmer. Okay, so this is checking the if x is on the left side of the room. So if x equals 0, then place west wall, and we'll just return west wall. Else, if x is equal to room size minus 1, place palace, place east wall. So then return east wall. Else if y equals 0, place north wall, return north wall. And then finally, else if y equals room size minus 1, return south wall. Place south wall. And I need to add my comments. If x is on the right side of the room, if there's a bug on my wall, if y is on the top side of the room, and if y is on the bottom side of the room. Awesome. Alright. Else return default. Okay. And then, like I said, floors, super easy. So we're going to attempt to just exit from the function, and if we can't exit from the function, we'd return a floor. Because we're not checking for anything. We know we're not on a wall or a corner, so we're just going to place the floor down. And this is just a simple square room, just to make sure that we get the basics right. At some point we could go in and add little fancier walls, put some random walls in there or whatever. Yeah. But for now, this is just the simple room. So okay, so that should be good. So if x is equal to start x, or x is equal to room size minus 1, or y is equal to star y, or y is equal to room size minus 1. So if it's here, 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 or here, the x or y value, it doesn't matter. Don't do anything with it. We don't want to place the floor there. Cool. That is that done. So now let's create a. Let's write up a quick constructor, and then I'll test this. So public dungeon generation. T north wall. T south wall. T east wall. This is where it gets repetitive and a little annoying. West wall, but it's worth it. T north west corner. T north east, no, northeast corner. T south west corner. I'm very interested in this. I'm glad you're interested in this. I love doing this. I did a lot of it a while back when I was like first starting out, but I haven't done stuff since. But I've kind of been itching to do it some more, and I would love to do it more often. T southeast corner. Okay, that's all we want. I mean, for now. Oh wait. Ooh. T floor. There we go. Yeah, we'll put a little summary on this that just says initializes all model constant values for walls, corners, floors, and I'll do it etc. Because we might do monsters that can spawn in here or loot that can spawn in here, all that kind of stuff. But just basics for now. But again, kind of in the back of my mind, I'm kind of thinking of where can I take this? What can I do more with this? What can I build onto this? While still keeping it very modular, very plug and play. It should be able to be compatible with anything. So I should be able to plug this into a console application, give it some random values, or plug it into a Unity application, give it some random values. It should be very, very streamlined in that sense. So north wall is equal to north wall. South wall is equal to south wall. East wall is equal to east wall. West wall is equal to west wall. Northwest corner is equal to northwest corner. Northeast corner is equal to northeast corner. Southwest corner is equal to southwest corner. That's southeast. Southwest corner. Do I sound like I want to? Do I sound like I hate myself yet? Yes. South east corner is equal to southeast corner. And then finally, floor is equal to floor. Cool. Alright, so that's done. And then we can call this. It is a public function, so we can call that from outside. And then we have the constructor. Cool. So what that means is now we can finally go back into the console application, and I can just run this as it is right now, just to prove to you it is a console application, while putting a breakpoint like right at the end. That way it stops and I can actually look at the execution. Otherwise, it does that if I don't have the breakpoint there. Okay. So yeah, you can see it's just a console application, just a blank. Oh boy, I just like let go of everything. You can see it's just a simple console, and I'm gonna plug some numbers into that. So right off the bat, we want a public list of type integer, and we'll just call this tiles is equal to new list. So then for tiles, we're going to, well, no, before that, we also need our dungeon generation of type. See, this is why I gave it the type. So now we can say of type int, and just say generation. So now see how these are the same. So now we're going to fill it with integers, and that will it will also then fill our list with integers. So that's why I did that. It allows it, even like in testing, it just allows for just simple testing. So we want generation, excuse me, oh, mother Hubbard, I forgot console, the main is a static function. Generation equals new dungeon generation of type int. So we're just going to go down the list. So 1, 2, 3, 4, 5, 6, 7, 8, and 9. I could probably do an enum that is just a list of all those, but this will work. I'll probably go through and do an enum here in a little bit once I get confused about what's what. But yeah, that'll be fine. So this is going to initialize our generation model with these values as the walls, corners, and floor. So then after that, we can just say tiles is equal to generation dot build dungeon. What else what else was on that? Just okay. I'll probably make these not public. I probably don't want to see those. I just want to see build dungeon. We'll say 5 by 5 by 0 by 0 because I'm not using those yet. What? That's of min. Oh, wait, what? hold on, hold Yanni. Why are you like this? Why are you the way that you are? 5, 5, 5, 5. We'll just do 5s. Okay, cool. Right? What? Oh, can I implicitly convert type? Oh. Can I just do .toList? Aha, I can. .toList of type int. There we go. Easy peasy. So we'll just run it there, just to make sure that our list of tiles even outputs correctly, even outputs at remotely what we expect. So it's a 5 by 5 or randomly between 5 by 5. Ah, yes, the zeros. I forgot about the zeros. Okay. Right, forget about that. So once we're done, before we return it, let's do a clean up default values. So it doesn't matter what default value type it is, we're just gonna say, and I want using system.link here. We're just gonna say temp equals temp dot where, or no, sorry. Yeah, sorry, no. Temp dot where, t equals t fat arrow notation, t dot, no, sorry, t is not equal to default dot to list. So now we're just saying, okay, temp, go ahead and find everything inside of you that is not the default value and return a new list of only those values. And then we're going to return that back. That's just a little last step cleanup. And now if we look at tiles, it didn't work. Why didn't that work? Well, let's see. Well, we can let's restart it and actually see what went wrong. So if we look at temp has 75. Can I like step into it? Yeah. So 5 is not equal to default, so that's good. So it's saying that, okay, so it's saying that default is null. What if I do default t? Wait, what? Oh, dot equals. There we go. And then we want not on that. Okay, there we go. So, I'm hoping for not 75 at this point. 28, okay. 28 I can live with. Okay. Awesome. So now what would be nice is if we get that room size value back so that we know what size it made. Because it's randomly generating that inside of here, but we want to be able to find that. So we'll say public public int room yeah, public int room, we'll do room width, get private set, and then again planning for the future here, public int room height, get private set. There we go. Oh shit. There we go. So then once we set that, and I'll change this to be room width. Again, planning for the future. Once we set those values, we will say room width. No, not that room width. Room width is equal to room width. So now we have that room width value that we can work with. So let's work with it. So now what I want to do is for int y equal to 0, y less than generation dot room. We'll do width for now because that's the only one I'm setting. And then y plus plus. We want to also then do for x. I was going to do a right line, but it'll just be easier, or at least faster, to do this. Console dot right. Cody McGrudy, Cody McGrudy. I love chicken beaks. Wild. Thank you. I have no idea what that means. So then we write wild. Fair enough. Okay, so then we want to write line. We want to write tiles. Sorry. X plus y. That'll be our index that we're looking for. If x is not equal to... Actually, no. Big brain. Console.write line. No, console.write environment dot new line. There we go. Wild. It means that I love chicken beaks. I don't know if I already read that, but awesome. Okay, so now what this should do is write those numbers to the console. It should actually put them in the grid order as well. Yeah. Okay. Not exactly what I wanted. So, so you can see here it's 51114. 51114. So 5 is the... Okay, so 5 is the corner, so that makes sense. Cool. 4 is a wall, which doesn't make sense. And 1 is also a wall, so that works here, but not here, here, or here, or here. So what went wrong there? Okay. What went wrong? Just making sure I didn't assign anything wrong. Okay, no, we're good on that front. Okay. So, the corners were wrong, but I might have... No, southeast corner. Okay. I'm just trying, before I run it, I'm just trying to look at it and see if there's anything that just sticks out to me as very, very wrong. But nothing is sticking out. So let's go through... So northwest corner worked and north wall worked. But then we did... But then it got to the west wall. Oh, that placed the west wall as well. That didn't even place the east wall. Weird. Hold on, let me run that again. That's really weird. And it's consistent, 5114. Huh. Okay. Okay, awesome. Okay, awesome, cool. Okay, just gonna go through them all that I have been saying all night. Okay. So let's see what's going on first with the northeast corner. Let's see why that's placing the wrong thing. Actually, let's see why it's placing the west wall as well. And I only want to run if it's actually going to go inside of it. Okay. Right, because it's a... Okay, so... So what's y then? Y is 1, x is 0, y is 1. X is 0, y is 1. No, that's right. Yeah, sorry. I don't know why I got so upset about that. Yeah, that's right. X is 0, y is 1, so that'd be... Yeah, okay. So something weird is happening, because in theory this should work. But for whatever reason, 51114. Let me look at what it is again before I do that final cleanup. Make sure I'm not removing anything weird. Because I have no idea what it's doing. I don't care about the northeast corner anymore. So temp 75, 5 1. So there's a 6 in there. 4 3 4 4. Huh. And then if I go through and hit, if I step over this, temp is 28, 511. So 6 4. Wait. X plus X. Oh. I'm an idiot. That's why. So yeah, the code was fine. It was literally me printing it back out to the screen that wasn't working. There we go. Okay, well, I stand horribly corrected about the code not working. So now we have a bunch of 1s. So north walls, where north walls aren't supposed to go. Six and 6 is south wall. 6 is northeast corner. Why are you down there twice? And then 4 is the west wall, which is just on a corner. So I've got corners on walls, and I've got walls on corners. Okay. That is less than ideal. So let's figure out what's going on. So firstly, let's look at this place walls. Because obviously we're overwriting a corner. So I want to do it for the 5th time through. Sorry, right? So where X is, so 1, 2, 3, 4, 5. Yeah, I want to do it on the 5th hit. Again, I'm an idiot. This is place walls. I want this to be place floors. So that explains why I'm getting... Okay, let's see if that actually sort of fixes that the floor problem. Because that would explain why there's a bunch of walls getting placed where a floor should go. Well, I have somehow made it worse. 5116. Okay, that's good. So that first one is fine. This is a good row. Cool. Why is it finding X as 0 there? And then 4 is... I should have done an enumerated list. 4 is the west wall, so that's on the wrong side. 9 is the floor. The 9 is just like here, hanging out. Okay. Alright. Okay. Um, let's just do. Let's just take this one at a time. Let's take this one little bit at a time now. Please don't crash on me, Visual Studio. God damn it. And it's not responding, and it's gonna crash on me. Where's my phone? There's my phone. Okay, cool. It didn't crash. Sorry, I'm checking texts. Okay. Okay. So let's test this one function at a time. And just make sure corners are getting placed correctly. Yeah, that's fair. Because tiles is probably what? Yeah, 4. Uh, let's just do this. Let's forget about this and just do console.write line. Tiles 0. Tiles 1. Tiles 2. And tiles 3. Just so I can see what the 4 corner values are. So it should be literally 5, 6, 7, 8. Cool. So the corners work. Cool. Good. I like that. Awesome. Now we gotta test the walls. Yeah, let's test the walls. And I'm just gonna do a loop of each. For each tile and for each eye and tiles, console dot write string I space. Oh. Okay. So that's good. Yeah, so I would expect then, so it would be, yeah, 1, 1, 1, 4. No, 4 is the west wall. Right? 4 is the west wall. Why is that? Okay, no, yeah. Okay, yeah. 4, 3, 4, 3, 4, 3, 2, 2, 2, 2. 2, 2, 2. Okay. Okay. So let's try those together then. So it should be 5, 1, 1, 1, 5, 1, 1, 1, 6, 4, nothing, 3. So that'll be 4, 3, 4, 3, 4, 3, 7, 2, 2, 2, 8 is what we should expect. 6. Yep. So that's 5116. Good. 43, 43, 43, 7, 2, 2, 2, 8. Okay. Okay. So the floor is the problem then. Okay. 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 So what is going on then with this? So we only want to do if x is less than, no, if x is, no, if if x is less than start x plus 1 and greater than room size minus 2, because that'd be room size minus 1 to get the edge, and then minus 1 to get the thing. So room size minus 2. Or and. We'll do or first. It's the same. It's gonna be the same thing, but with y. So y and y and y and x. So let's try that. So now that we have that, let's just redo this. Let's print it out in our grid format. No. The name capital Y does not exist. Well, why did you let me type it? Okay. Well. And now we've really broken it. So let's not do or, let's do and. So we want to. So both of these have to be in between the thing. Is what we want. Nope, nothing changed. Do it again. Just make sure it wasn't a fluke of a last running program. 555. Nope. Okay. For right now, for right, no, because that's just gonna overwrite everything with 0. So what is going on with it now? So let's just put a breakpoint on it. Let's just see what's going on. So x is 0, and start x is 0. So x is less than start x plus 1, which would be, yeah, so that's 1. So we're already not on the floor. So we should, if I step... Oh, okay, okay. So this returns false. Oh, I was doing ands. I was saying if it's if it's literally saying if it's on the left side and it's on the right side of the floor. Okay, that was why. I needed to be saying if it's on the left side or the right side. So that should fix it. Why is it the what? Now you're just fucking with me. Oh, because now I'm doing tiles y. X plus y. God bless it. That was still an issue though, like that. Oh, damn it! I just like yeah. There we go. Okay. So what happened there? So that was weird. That was 51911. Okay. So start x is 0, x is 0. I'm gonna pin these so that I just have them available. There we go. Okay. So now I can see those at all times. So that's true. And that's true, so that should be true. Okay, which, yeah, so that returns default. Cool. So next time we come around, x is now equal to 1. So x is not equal to less, it's now... Okay. Yeah, so it's now equal to this, so it's not less than. So now on our x side, we are technically off the left wall. We are off the left wall. So now we need to check the right side. This also has to be an OR then. Because this side is still true. We're still along the wall. Okay. That was why. I did 3 ands and I just needed 3 ORs. That was the whole problem. Well, I spoke too soon. So now we're back to this. So now why did this happen? So the first 5 were fine. So 1, 2, 3, 4. Okay, so now this is where the problem starts. So we're less than that. But we're not less than that because the y is now down 1. Wait. Oh, because it's equal to 1. But this is still... Okay, but this is still true. That's true or true. Okay. True or false, so true. So it should return default, which is what we want. I have to figure out why the wall got placed wrong, but... That might be it. So the same thing we're checking for down here is what we need to check for up here. Start. No, not start. Is less than room size -2. And then same with this. But instead of x, it's y. I think I'm kind of guessing now. Okay. Okay, so the wall code was fine as it was. Because we tested that, it worked fine as it was without the floor. So the floor is the problem, because the floor runs last, so the floor is overwriting everything. Let's okay, let's test it this way. So if x is greater than or equal to start x plus 1, and x is less than or equal to room size minus 1 minus 2, and then similarly on this side. So instead of checking for what it's not, check for what it is. Else return default. Okay, so we're back to this. Why are we back to this? Because I didn't change that to be an and. What? No, I don't get it. I don't get it. Let's forget the grid output. Let's just see if it's running it just straight across. 516. So okay, so it's the way I'm printing it out then? Okay. I guess that makes sense. So 51116 49993 49993 49993 72228. So it's the way I'm printing it to the screen then. So really I could just do int y. It's toying with you. You can beat it, Trey. Yeah, I figured it out, and all it is that I'm a dumb. So all I have to do is just, I mean, if I want to see it in that grid layout, which I do, I want to verify that it works like that. I would just do this. So console.write. God, I can't talk. Console.write line $ this. Tiles y plus 0, so just y, tiles y. Space tiles y plus 1, space tiles y plus 2, tiles y plus 3, tiles y plus 4. And then new line. Sorry. Wait, what? Oh. There we go. So that should work. That should print it out in the the grid layout. Whatever. We've seen that it works. It's not printing it out this way, but obviously, if I wanted to, I could print out. I could do a quick struct of tile. Give it a int x equal to, or give it an int x and a y, right? Public. Yeah. Mom says hi. Hi, Mom. I could do this as type tile, and this is type tile. Give this a string. Name. But yeah, so I mean, it works. Obviously, just printing it out to the screen is a little difficult. So I'm gonna chalk that up as a win. And we'll just keep using the long printout version of it, and just keep our stuff small. Just because right now I'm just a little too lazy to try and figure that out. So that is the basic dungeon script. And that'll work with any type. So here I'm feeding it int, which actually I don't even need that list. So here I'm just feeding it integers, but it could be anything. Obviously, because you see me start to set up that structure. So now, let's do... I'm trying to think. I'm just making sure. I'm just going to once over, make sure this is how I want it. Oh, you know what? So a dungeon needs a door. We need a way in and out of this little dungeon room. So this is gonna have the same parameters as everything else. So now I'm back in my pseudocode before I go into the actual code. So now I'm planning again. And if I pull up this lovely drawing, so we covered all this. So now we know we've created everything here. And this is your walls, your corners, and your floor. Just in case it wasn't clear. Floor. There we go. So now what we want to do is potentially place some doorways here. I don't know why I did that door sideways, but you get the point. So we would need doors, and we could do... So we always need the door we came from, and then any other door is random. But we always need the door that we came from, because we have to be able to get out of the room we just walked into. Okay. So we'll take our last location X and our last location Y as integers. And that will be where we place the door the first time. We would want a direction we were facing, so... And we can do that as an integer as well. Or as facing, and we set up an enumerated type. That's just north, south, east, and west that we can pull from. Makes the code a little bit more readable. Does the same thing, but makes the code more readable. So then if we're facing, say, north, we would want to use the last x value to see where to place it along the south wall. Because we've been facing north, so we're going up. So we want it on the bottommost wall. So let's start with that. Let's start with just creating the last door. I'm just looking through, making sure there's nothing I can pull from. No, so this will run after the room is created, then we'll place the door down. So this is going to run over top of everything else. We only want to place it if it's on a wall. We don't want to place it on a corner or on the floor. So basically we're going to do the same thing as this. Yeah, so we're going to do the same thing as that. Right? Yeah, okay. And then do a select case of select case based on facing, which will basically do if north, then place door on last block X on bottom wall. If south, then place door on last block X on top wall. If east, then place door on last lock Y on, so we're facing east, so on west wall. And then finally, if west, then place door on last lock Y on east wall. Alrighty, I'm hopping off. Long day. Hope this goes uphill for you from here. Have an awesome night's sleep. Thank you, you too, buddy. Thank you for sticking around. And like I said, hopefully I'll do more of these. And then we'll end the select case. So we would want then 4 more model types, which would be for the 4 doors, just in case you want to have a different door texture. So let's start with that. Let's just get the initial place door done with just placing the door we came from. No problem. It was fun to hear you talk your way through this. It was fun to have a medium to talk my way through it where I'm not crazy and just talking to myself. I'm still talking to myself, but I'm screaming into the void at the very least. So again, private T, place doors, and then same parameters. Yeah, I'm glad you liked that. All right, good night. Night, man. Good seeing you. And then last lock X. My Visual Basic is taking over, and I'm doing like as int, like I'm doing over in my pseudocode. Int last lock Y, and I want to do that enumerated list. And this is just gonna be yeah, we'll do public. Because I want other things to be able to use that. So public facing. Nope, shit. Public enum facing north, south, east, and west. So that I can say facing. Perfect. So we're gonna copy from the place walls because it's gonna do the same thing. If we're not on a wall, I don't want to do this. Otherwise, we'd be placing doors on corners and floors, and that doesn't make sense. So then we'll do switch based on facing. Case facing dot north. Return. I forgot to do this. North door, north door, north door, and north, or I don't know why I'm saying north, but I just meant door. We'll add those into that here in a bit. Not important right now. Okay, so can't do a switch statement as much as I would like to. I still have to check if we're along certain walls. So if facing dot north and y is equal to room size -1, then return south door. Right? Yeah. What's your problem? If facing equals, there we go. Else if I'm just gonna copy this multiple times and then change it. Facing dot south and y is equal to 0. Facing dot east and x is equal to, so we're facing east, so we're coming from the west, 0, and then west, x. Okay. So then we want the north door, not northeast corner, north door, west door, and east door. Yeah. Else, return default. Okay, so that should be good. And it's the exact same code as the wall code. We're just also checking for a facing direction. I guess it's not the exact same. It's opposite of the replacing opposite of what you would expect for that. But yeah, so now we can do, just come here, copy this, do place doors. For now, let's just do player last x is 0, 0, and then, oh, that's right. We're just gonna be facing south. We'll say we're coming from the. So we also need to include then, and x is equal to last lock x. Because we don't want to place it every time, that we only want to place it when, from where the last location x is at. That would have been a real problem. That we would have had doors for every wall that it met that criteria for. Why? Why did I do that? There we go. No big deal. Okay. So now we just gotta add a, let's start minimizing these. I'm done with these. These are good. This is also good. For now. So let's take this. I'm just gonna try and keep these in the same order that I have these in order. Ooh, it's already midnight. I've been streaming for 2 hours now. So I'll have to go to bed soon, but that's okay. North door, south door, east door, west door. And then we'll take this. Oh boy, I didn't want to do that. Copy this. I am really glad I implemented the generic type T there. That is, I think that was good thinking on my part. I did that. I learned that while doing a. I was writing a JSON sort of saving library, so saving for a game, saving everything to JSON, but I didn't want to have to write the same code multiple times. So I just said, hey, take this and run this function with this generic type. And it was easy. I loved it. So I learned how to do that, and then obviously that translates over to this. So that was a super useful thing to learn how to do. 10. You know what? We'll do hex because I don't want to have to do more than one character. So A. Oh, I can't. Okay. String. Car. 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 A. B. C. D. And we'll update the rest of these. Yeah, I don't want to. I don't want to have multiple. I don't want to have multiple spaces and have the. I guess I can't do the grid anyway, but this way it kind of we're just sticking to the one character while we do this. Makes it a little bit better. And here's just my proof that you can do it in any format. So we won't have any doors, I just realized, because I didn't change it from 0, 0. The last location was 0, 0. But I guess if we run that, that should be proven. Is it 0 in there? Oh, I think I think we're printing the ASCII values of those characters. Wait, what? Yep, that's exactly what, because I'm doing it as an int. That's actually pretty cool. That's a I didn't know that existed, but I don't want that. I just want the actual character. There we go. Get back down there. So 5116 49993 49993 49993 72228. Right, so no door. So that's exactly the same as it was before. All right, it's gonna bug me. This is time wasting, but I don't care. I'll do what I want. If I mod generation dot room width equals 0, right? Yeah. Put a breakpoint there because I don't remember what I always forget the order for modulus. So I is oh shit. Right. For int I equal to 0, I less than tiles.count, I plus plus, bam. And then we want to do tiles I. Okay, this is wasting time, but I just kind of want to do this. This will help me in the long run when I'm doing more testing with this. So I is 0. So let's just see what this looks like when I not let it, do that. 5 4 4 4 7. Cool. Else console dot write environment Actually, let's just do this. So why? So. So let's do the other way. So, yeah. Divided by 0. Right. So we do want it the other way around, otherwise we're going to get a divide by 0 error. Again, this isn't important, but... Okay, went a little radio silent there. I'm just trying to think through this. So this should be what I want. This should be the proper setup. And then I just do console dot right tiles. So x plus y. So x and y are 0, so that'd be 0. Y would still be 0, x is 1, that's 1, 2, 3, 4. x would go back to being 0, y would be 1, 1. Oh. What is the formula for converting 2D index to 1D? There we go. Row times okay. Okay, cool. So it's x times generation dot room width plus y. And then after the fact, console dot write d, 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 not that. There we go. Alright, that should work. Again, not important in the slightest, but now I got that. Perfect. That's all I wanted to see. I seem to be rotated now, though. Yeah, so I've shifted it. So we want to column concentration, so the other way around. There we go. Awesome. Again, not important, but now I have that visual. And fuck it, we're already wasting time. Space. There we go. There. So now we have our grid layout. I like that. So now let's get those doors back in. So now let's change. It's a hard-coded value, but let's just change this our x to be. So we're facing down. Let's change it to be 2. Okay. Okay. I really throw a wrench in that, apparently. Oh, because we're adding it. I want to replace it. So I shifted the whole thing. It's wrong. It went with 5, but that's probably a... No. But... Oh, yeah. It was a logic error. I thought I did that, but I guess not. Okay. So yeah, the 5 being there was my fault. But the problem is we added it on top of the wall. So for when we're placing doors, we want a reference. Well, it's already we want a reference to that list. And then before we... So instead of returning, so this is not going to be added. We're going to literally replace the tile that's there. Okay. I think that's good then. I think that's what I want. I need to actually set it up so that it sends that reference. Temp. Yeah, then we don't need this anymore because we're not adding a thing. We're just... And I mean, we still could, but we're already... Because we're already going to remove it, so we might as well just set it equal to what it is now. We may as well just overwrite it. Okay. So that's not what I wanted to happen. Uh, why can I not? Huh. Oh, because I... right. Tiles.remove at... So let's... let's change it all back. Okay. Tiles.remove at... Let's remove it at that index. No, we want to replace it because we want to... Well, but we're already going to be... It's running simultaneously. So yeah, that's fine. That is fine. See what that does instead. There we go. Well, no, it still shifted it. It still placed it right in the middle. So, let's see what's going on. So we're facing south. So tiles don't remove at... So tiles... So that would be... Jesus, okay. So 2. Okay, yeah. That's what I want. No, it's not, because we still have all the default values. Crap. Okay. So after every time through, we have to remove the default values. And I guess at some point, I mean, I'll go through and refactor this at some point. That'll be the highest priority that I need to do is we don't want to run this every single time. We have to, like, we don't have to clean it up after every add. We want to just not add the default value. But this is kind of the best way right now. Quickest way, at least. Not the best way, but it's the quickest way. But that's also still not that bad. So now that that's out of the way, there we go. Yeah, so the problem was it was removing default values from the list instead of what it needed to. So then the A was just getting added in still randomly and then not taken out or not shifted back to normal when the default was removed because it was added into the list. So yeah, that is what I want. Awesome. I love to see that. And then if I change that value to whatever, and obviously I could make this like you enter these coordinates in when it starts, but this is just quick and dirty. Oh, but I'm not facing. I see. Okay, so that worked too. So coordinates are here, but I'm not facing that direction. So let's do facing. So we're coming from 0, so we're facing east. Yeah. Ideally, these would be, you would want these to line up with whatever direction you're facing. So D. Yep, there we go. So getting the last known door position works. I'm gonna do one last thing and then I will call it. So we have a good square, but obviously I had it set up to do, or had planned to do, a random width and a random height. So let's get into that. So I'm just going to copy this line, change this to be random height. This is going to be min height, and this is going to be the max height. Oh shit. And I don't really think we'll have to, we won't have to change anything down here. Right? No, we will, because the room size has to be, we would need to be the room width and the room height. So we will have to change those. This will be room height. And while we're at it, we'll set the room height. Awesome. Yeah, okay. So, yeah, we need to clean up this then so that these accept a room width and a int room height. So x is fine, but then we want this to be room height. Basically, anything dealing with the y needs to be changed to be room height. Room height. Okay. So this is just going through, cleaning up everything that I'd already done, and fixing it to be this now. Weird. Okay. There we go. But once this is done, that will give us the room modularity. So it's not going to be a simple square room, it can be a rectangle room of any size, which would be great. then int room height. So that's the floor, and then we need the doors. Int room height. Awesome. Okay, so then just change these. Change that. Sorry, just the one. Oh, no, wait. So we would need this then as well to be the room height, I think. Yeah, because it's not a perfect square, so we would need to know the both dimensions. And just for consistency, let's not use the public. Let's not use the property on that. Let's use the actual variable we're sending. Okay. So now everything needs the room height. Okay. So now if I run that, in theory, I should get a random sized. Okay, it's still a square with my door on that side. But now what if I say, okay, go ahead and build anything between 5 and 10 on either side. So my room, oh, because this needs to be room height now. So not a problem with my generation code, at least not yet. Problem with my testing code. Okay, no problem yet. And there we go. So you can see my corner, my walls, corner, walls, corner, walls, corner, walls, door, wall, and then my floor. Perfect. And that is not a 5x5, that is a 5x6. And let's go bigger. Let's say 20 on the width. Let's say 20, not 200. Let's say between 10 and 20, and then 5 and 10. So force it to be a rectangle. There we go. And so all those are correct. That our 9 is the floor, 1 is our wall, 2, 4, 3 are walls, D is a door, 5, 6, 7, 8 are our room corners. Awesome. So now we can have any size and rectangular shape room. So that is what I'm going to leave this stream at tonight. Thank you for people that stopped by. And if you would like to see me do more of this, just tell me. I have a lot of fun doing this kind of stuff, and there's still more that I would like to add to this project. So we can add. Obviously, this is the door that our player theoretically would have come through. So we can add in random doors now throughout the rest of this place. We could add in some loot chests, sort of in a different layer or something. We could add some mob spawn areas, something like that. So yeah, definitely let me know. And if you just want to see other programming stuff that I do, let me know. But yeah, that's going to be it for the stream. Thank you for watching. And peace out.